Okay, so go to the Add menu, and then under Visual Effects, you will see that the first one that we need is the one that we need, called Post Process Volume. So post process, as the name suggests, it is something that it's like a filter, right? So if you use Photoshop or some other cameras or video editing, it's basically just like a filter that adds some visual effects to the screen, to the entire 2D output on the screen. So it doesn't affect the actual 3D environment, but it's just, think of it as a filter for any type of visual effects that layer on top of whatever visual outputs you have right now. So let's add this into our 3D environment, our scene. You'll see that it's represented by this empty box here. And then let's drag it into our lighting folder so we have a better organization. So this post-process volume has a lot of settings. All of them control, you can see their names. If you're familiar with some of them, you'll see that they are all related to the visual outputs, the visual effects. For example, like exposures, right? Lens flares, image effects, depth of field, all of these things, bloom. So we will talk about more of them later on. But today, what we need to do is only two things. There are only two things. First, if you scroll down to somewhere in the middle, there is a sort of a section called Post-Process Volume Setting. Maybe it's a little bit difficult to find. Then you maybe just collapse all the other menus. So you scroll down until you find this post-process volume setting. So it's maybe somewhere in the middle. It's a little bit difficult to find because there are lots and lots of settings in this post-process volume. But you find here, and then you see there's an option that says Infinite Extend. We simply need to check this checkbox. We enable this checkbox. So think of this post-process volume. It's represented by this box. So currently, all the without checking this box, all the visual effects that you change, that you enable, will only affect the area inside this box, right? So as soon as your camera go out of this box, then it wouldn't take effects. It wouldn't have any effects after that. After you move out of this box. So by checking this infinite extent, it will ignore this volume completely. It will just affect the entire world. So it's easier to manage. So let's enable this checkbox, Infinite Extend. If you cannot find it, you can just search, type in this search bar, Infinite. Then you will be able to find this option. And then with that enabled, the next thing we need to do is to scroll up to the top of the list again, and then you will see an option called Exposure. You'll see a menu section called Exposure, right? Exposure, 曝光度 or 曝光. So here it controls the lighting measurements in our 3D environment. So under exposure, there are two options that we need to checkbox. One is the mean EV. The other one is the max EV. Check these two checkbox and then set them both to 1. Yeah, exposure and then mean EV and max EV. Just enable the two checkbox and then set both to 1.
Who's is in Chinese? They can't, they're lost if they're in Chinese. Who's on wheels in Chinese?
Again, please use the English version. Also, Jiwen, do you remember the comment that you said last time, changing
I'm doing a culture equal to
the changing the UI size?
Right.
Yeah. Do you remember that one?
Shift Command P.
Okay.
Shift or Shift Control. I have to look at 1 second.
Okay. Is it too small also?
Control Shift W.
Oh, Control Shift. Thanks. Control Shift. Anyone here couldn't find the setting?
Did you get it? Well, did you find it? Yes, no?
Also, is there an empty machine? If your laptop doesn't work, there's another computer here. Okay, so this is a simple setting, but it's important because if you don't have this setting in the future, then your games, whenever you start playing your game, the lighting will be wrong. So please remember this. Yeah, maybe on some of your engine version it says mean and max brightness.
This is the sign. It's the same thing. If it's this low, look at how slow it is.
Yeah, it's very important that you can follow all the steps in the class. So because after you if you couldn't follow up, then when you're by yourself, it's gets even harder, and you probably don't have too much time to watch all the tutorials. So it's important that you can at least try to follow all the settings in the class, all the sort of steps. Okay, so on some of your engine versions, it might be called a different name. It might be called a minimum brightness or maximum brightness. It's the same thing. Just set them both to the same number, like in this case 1. Then it will not have any sort of this automatic exposure when you start playing your game. It will stay exactly the same as how you set it to be. Yeah, if you cannot find it right now, maybe take a photo of my UI here, and or you can maybe find it later. So it's just under exposure. Okay, so now we have finished setting up all these what we left from the last class about lighting. So now we can start talking about the exciting parts of today's content, which is Unreal blueprint scripting. So let's go to the content drawer, go to content, go to the root folder, and then create a new folder just called blueprint. Right click and then new folder and then blueprint. So in this folder called blueprints, let's create our first blueprint object here. So let's right click again, and then you'll see that there's an option called creating a blueprint class. So let's click on this one. You'll see a new menu, a new window pop up, asking you what kind of blueprint object you want to create, what kind of class it should be. If you click on this expandable menu, you can see that there are many different type of blueprint class that you can choose. And then here on the top, it shows the common ones, the commonly used one. We simply use the first one called actor. So blueprint is just sort of a wrapper or this kind of object for all the kinds of objects, functions that you can create inside Unreal Engine. They're all called blueprints. So you can, a character will be a blueprint. A game mode will be a blueprint. Any objects that the player can interact with will all be blueprints. So you can think of blueprints as simply as sort of like a wrapper objects for all the things that you can create inside Unreal, inside the game engine. And we choose the most common one, actor, and then name it BP underscore. So for the first one, let's call it light control. So our first blueprint, we will basically be creating a light, an automatic light, with some sort of a sensor, so that when a person or your character walk close to it within a few, within certain distance, it will automatically turn on, and when the character leave the area, the lights will automatically turn off. So it will be, it will sense your character, and it will save, save energy, save the planet, right? So let's call it BP underscore light control, and then we double click on this to open it. So we have this new interface, this new window. Also look very complex, very scary, but let's just try to break it down, so that by the end of today's class, hopefully you know how to create and edit a simple blueprint object. So let's see how this window is made of. So on the left, it has this component menu, and then some other sort of functions, another menu for functions, events, and macros. In the middle, you have the viewport, which is just another 3D viewport for you to look at this blueprint object. And then if you click on this tab next to viewport, you'll see there's a construction script and event graph. Let's try click on them, take a look. So here is basically the visual scripting environment, the programming environment for us to do all our scripting and programming. Construction script and event graph. So if you study programming in other language before, here is basically just your text editor. Here you edit, you create all your events, functions, all of them inside here. And then on the right side, it's simply just a detail editor to edit some properties. So depending on what kind of things you selected in the graph, they will have a different property for you to edit. And of course on the top we have the basic menus. So let's start adding things to this empty blueprint object. Okay, so since it's a light control, the first thing we probably need will be a light, right? So we actually have to have a light. So let's make sure we are in this viewport tab. On the left, you'll see components. In this little window here on the left, top left, you can add different things to your blueprint. Here, let's click on this add button and search for light. Here you see all the familiar light types that we used before, including the point light. So let's add a point light, a simple point light to this blueprint. Yeah, so on the left you see component, and then add, click on the add button, and then add a point light. Click on add, and then scroll down. Somewhere in the middle you will find point lights. You can also just click add, and then in the search bar you can search for lights. Then you will see point lights. So and in the viewports here, you also see the light icon being added. If you click on this light, this point light, you see all the familiar settings that we talk about on the point lights on the right side on the detail panel. So it's exactly the same point lights that we used before. We have intensity, we have light color, right? All of these are familiar properties. except now it's not just a simple point light. It's being included in the blueprint object so that we can do some programming using it. So for demonstration, for a good sort of visual indication, let's already place this point light into our environment.
Everyone should. I would recommend bringing an external hard drive so you can. If you need to use a computer.
Yes.
I don't know. I never see that, but it says expect extremely poor performance.
Yeah.
At this time.
What's happening?
He's getting a video memory has been exhausted.
Oh.
So.
Yeah, then it's probably which laptop?
Just a tutorial so you can use this.
You can still use it, but later on maybe try to.
Or just remind this.
Alright.
It's a $5,000 USB that I don't use.
Yeah.
This is sort of you don't need the file. If you really need it, you can get a external and plug it in. See.
Yeah. So let's already drag and drop this new blueprint object that we created into our environment and take a look at its effects. So you should be able to see that it's just a regular point light that we used before, right? Okay, and inside this point light, let's double click on our blueprint class again. Right now it's just an ordinary light, so if we play our game, start playing our game, we see that the light is here, it's bright, but it won't do anything, right? It's just like a regular point light that we used before. In order for it to, for example, be able to recognize our character, we need to add a new component to it. So let's open our blueprint object again. And under this component menu, let's click on this add button again. And this time, search for box, B-O-X, box. So click on add, and then in this search bar, search box. So the first thing you'll see is called box collision. It's a 方块状的一个碰撞体啊 OK box collision. So let's add this into our scene. So now you see that there is this empty box surrounding our point light, right? So if we go back to our 3D world, you'll see that it's the same. We have this empty box surrounding our point light, but right now it's quite small. It's very small. So let's go back to the blueprint, select the box, and scale it up. You can edit its scale on the right here. Just make it 10 so that it's a much larger box like this. Okay, so we have now a box collision and a point light, and the box collision we should set its scale, all of them to 10, so that it's a much larger box. Okay, so these are the two things that we need to do. So I'll give you 1 minute. Make sure everyone can have these two components in their blueprint.
这为什么我这边显示这种这边没有？
哦，对，
对，不是，就是我看你就是这边就是加完之后在这边有。
那个是你要把这个东西做到那个，就是在这个这个是，
多久？
做个看见之后，再去分一个。
哦，就是那哦。
Anyone having any questions? It shouldn't affect the programming part, so maybe let's.
It might be about if I say
Yeah, and reopen. Okay, so let's continue. I think most of you got it. Box and point light. So let's make sure you have these two things here. Now let's go to the event graph. click on this event graph here, we will start to sort of do our programming here. So make sure you're now on the event graph. Oh, and also everyone make sure you remember to place this in the 3D environment, right? You need to actually drag it into the 3D scene for you to be able to see it in your game environment. Now go to the event graph, and let's talk about what these are. So you see there are three sort of default nodes here. All of them, you know, with the red heading. Whenever you see a red heading here, red tab, it means that these are events. Events are simply things that take place in the world or happens in the world. It doesn't need any other things to lead to it. It simply can happen by itself. And these are the three default ones, or most commonly used ones. And they will exist in all the new blueprints that you create. So we can actually safely delete all of them. We don't need them. We can start from zero, starts from ground up. So let's recreate them. All right. So delete them, and then let's recreate them by right-click, and then search our first event, which is event begin play. So you just right-click, use your mouse right-click, and start typing. This is the, if you are, if you've done programming before, it should be pretty easy to understand. But if not, you just again right-click and start typing, begin play. When you type this, you'll see that this is the event begin play. You can just click on it, and it will recreate this event in this graph. So by just as its name suggests, this event takes place whenever you start playing your game. When you hit the play button, this is the first event that will be executed. That will happen. So basically, this is, think of it as like the starting point of all the actions in this blueprint, right? So when you start playing your game, something will happen. And what we want here to happen is that we want to set the intensity of the point light. So remember, when we create our point light, it has the default intensity of 5000. That's why when you move it into the 3D scene, it's already, lighting up this area, right? So when you move it into your 3D scene, it's already lighting up this area because it has a default intensity. What we want to do here is we want to set its intensity when we first play our game, when we begin playing our game. In order to set the intensity of the point lights, we need to have a reference of the point lights in this graph. So let's on the component menu, let's drag and drop this point light into the event graph. So we have a reference to it. Now it turns into another node in the graph. Just drag it into the graph, and you'll see that there's this little blueprint, this blue pin on the right side of this node. Let's use our left mouse button, hold down left mouse button from it, and you'll see that you can draw a wire like this. And if you let go of your left mouse button, you'll see this list again. Here is a list of all the actions that you can do, to this point light, right? Here we want to just do a simple thing. We want to set its intensity. So remember the word set. If you're not familiar with programming before, just remember this word. It's one of the most commonly used words you'll see or you'll type in the blueprint scripting environment. So remember set, set, right? And then intensity. Because the environment is very smart, it already knows, set intensity is probably one of the most commonly done action to the point light. So it already, let us see this set intensity action, this or this function, when you type set. So let's just left mouse button and click on set intensity. So now we have a new node called set intensity, and under this node you'll see that, right, we have a few sort of parameters. We have the target. This target pin is already connected to the point light, meaning we are setting the intensity on this point light. It has a target, right? And then we have a float, we have a number here, a float number called new intensity. Here is the part where you want to input, the new intensity, the new lighting intensity you want to change it to. Actually, in this case, we just want to set it to 0 because we want to have the light turn off at the beginning. So let's just leave it at 0. So now we see that there's also this node. It has a blue heading, and it has this little pins on both the left side and the right side. So this thing is a function. You can see this. There's an F here. It's a function. And the order of the execution of all these functions in the graph is pretty easy to understand from left to right. So what we need to do right now is just to connect this pin from event begin play to the left pin of the set intensity. Okay, so now we have finished creating our first very simple function that actually does something. So we have event begin play, and we have this white line connecting it to the function set intensity, which means when you begin playing your game, it will immediately set the intensity of this point light to 0. Okay, so this is the very simple logic. I hope everyone can understand. So let's try this, but before we try anything, every time we finish programming something, we need to compile it so that the software can register all the changes and see if there's any error or mistake. So you see there's this compile button on the top left. So every time you make a new change to your blueprint, you need to compile it before it can actually run properly. So if you change something, for example, I do something here, you'll see that the compile button turns into a new look with a yellow question mark on the left, right? That means you haven't compiled this blueprint, and therefore it doesn't know if it will run properly. If you click on compile, it shows you a green check mark. That means your programming doesn't seem to have any issue. So there's no bug, basically, and it should be able to run correctly if you see this blue check mark. So now let's go back to our game environment. So we see in the editor mode, it's still the intensity of this point light is still at its default of 5,000 5,000, right? If you click on it and then select the point light component in this blueprint, it still have the intensity of 5,000. But when I start to play the game, you'll see that everything is completely dark because exactly because of what we just programmed, right? So we program it to be have the intensity of 0 when we start playing the game. Okay, so this is the correct look. Maybe you're not so sure, right? Maybe you want to test it before you can you want to just make sure that you program everything correctly. You can maybe try to set the intensity to something else, like a much larger number, or a smaller number like 100 just to test it. Okay, so at least you know your blueprint is running correctly. So you can set the new intensity to some other number just to make sure that your blueprint is running correctly in the environment. So for example, now I just set it to 20,000. I set it to like 2,000, which is a much brighter light. And you hit compile, go back to your level. You should see that when you start playing your game, you'll see a much brighter light here. That basically means, you know, your first function or your first blueprint has been created correctly. So now let me walk around and see if you have any questions on this first part. For anyone with a programming background, it should be very, very simple. So but just be patient, because we need to make sure everyone is follow the simple follow. Let me actually show it on the big screen. Okay, so everyone please pay attention. If you're not using the map that we created from last class, if you're opening up another map, sometimes when you start playing the game, it doesn't have a character, right? In this case, we need to go to Window, and then go to World Settings. You only need to do this if when you hit play, when you start playing the game, it doesn't give you the third-person character. Then we need to change something here. So go to Window and then World Setting. Here you'll see something called Game Mode. If your game mode is something else other than none, then just click on this menu and then change it to BP third-person game mode. If you cannot even find this third-person game mode, then you maybe have another problem, which is that when you create your project, you forgot to create it as the third-person template. In that case, maybe raise your hand and let me know. If you cannot find this BP third-person game mode, then please raise your hand. Yeah. So if some of you cannot even find this third-person game mode here, that means when you create your project, you didn't use the third-person template. In this case, we can still add it back in. You can open your content drawer and then click on this Add button, and then choose the second one called Add Feature or Content Pack. And here you'll see the same window when you first create your project. In this case, just select third person and then click add to project. Yeah, I'll show again. So if you cannot find the game mode, third person game mode here, go to content drawer and then add feature or content pack, and then find the third person, select the third person templates, and then add to project. Once you have that, just change the game mode to third person game mode. And now try to play your game and see if you have the third person character. So now I will actually move on to the next step because we need to balance both time and having everyone up to speed. So maybe if you have any other questions, let me know during the break so that I can we can finish today's content. But make sure everyone has the third person character. Because the next step, in a few steps later, we actually need to use that thing. Okay, so now we already finished this first step. Let's set its intensity back to 0. Set its intensity back to 0. So the first set intensity function. Under new intensity, we set it back to 0, and then now let's create a new node by right-clicking on somewhere empty, and then let's see begin overlap. Let's search for begin overlap. So right-click. And then start typing this word, begin overlap, until you see this this function or this event called actor begin overlap. Click on it and create it in the event graph. So what this event does is that it will be triggered. This event will happen, or whatever all the other functions that follows this event will be executed whenever this blueprint is overlapping with something else in the game. Okay, so overlap meaning maybe it collides with something else, or maybe someone walk into the area of this volume, then it will trigger this event and all the functions that follows. In this case, we want to set the light intensity to a new value, right? So whenever someone walk nearby or walk into this area, we want to turn on the light, meaning we want to set its intensity to a new value. So of course we can do the same thing here, like set intensity and then have the point lights, etc. But we can also just copy and paste. So we select both of these two nodes, set intensity and then point lights, and then we hover. We can Control C and Control V, but we can also just duplicate it. So we select these two, and we put our mouse on somewhere empty, and we press Control D, as the first letter of duplicate, Control D. Now it makes a copy of these two nodes. And let's connect actor begin overlap with this set intensity. And this time we want to set it to a very bright value, like something like maybe 10,000. Okay. Is this clear? So we have event actor begin overlap, and then after it we have set intensity. This time we want to set it to a very high value, like 10,000. So now if we go back to our game environment and we hit play, so at the beginning it should be dark, right? Because its intensity at begin play should be 0. Now when I walk towards it, and when I walk into that, the big box that we put there, the lights automatically turn on for us. Let me try again. Maybe try again. So I give you a few minutes to finish this part. Make sure this part works correctly. So at event begin play, set its intensity to 0, or maybe set it to like a smaller value, like 100, so you can actually see where the light is. And then after event actor begin overlap, set its intensity to a much larger number, like 10,000. Everyone try to sort of recreate these simple steps on the screen. The box is too big, so your character when you start playing already inside this little box. So maybe so that when you start the game, you're trying to get so much inside. And it will disappear because this box is just a standard object. So when you play your game, the yellow box will disappear because that's not an actual game object. That's just something that you see in the editor. Okay, so the first step. Any questions? If most of you managed to do this, then the following parts will be much easier to understand. Okay, so I think most of you got it, so let's move on. So this is interesting, right? So we can now turn on the lights. Let's do the same. Let's do something similar but opposite to that. Let's turn off the lights when our character walk out of that volume. So that's also very easy to do, right? So I think once you get this part, the following will be easy. Just right click. Now this time search for the event end overlap. So previously we have begin, now we have end overlap. So begin overlap and end overlap. Let's also duplicate these two nodes, Control D, and then connect them together. So now we have this very simple function, event actor end overlap. We want to set its intensity back to something like 0, which means when our character walk out of this yellow box, when we stop the overlapping, then it will turn off the lights. So let's try this. So we walk into the area, the lights turn on. When I move away, it turn off. So this is the final results that you should be getting. And it's just achieved using some very simple actions, right? So we have begin overlap and then end overlap. So this part should be easy, right? Because once you understand actor begin overlap, you should be able to create the exact same thing. Just using actor end overlap, just set its intensity back to 0. Okay. So now we created our very first simple interaction in our game. So our character can now turn on and off this automatic light, with a sort of proximity sensor or whatever, so that when your character walk into its sensing area, it will be turned on. When we walk out, it will be turned off. So very simple interaction, our first interaction. Okay, so but let me point out also that this light actually has a problem, an issue. Let me do something here to show you what's the problem. You can follow if you are very quick, but you don't need to follow this exact step. I'm just trying to demonstrate certain things. So in my blueprint folder, I will right click, create a new blueprint class, and then select actor again. This time I just call it BP_cube. I will create a simple cube again. Click on this blueprint to open it. This is an empty blueprint object. On the component menu, I will add, and then I will just add the simple cube. So that in my blueprint, in the component, I will have a cube here. And with this cube selected, I go to its detail editor, and then I scroll down. There's a tab called physics. I just enable simulate physics. Again, this part you don't have to follow, but if you are very quick, you can follow me so that you see the effects by yourself. So I enable simulate physics. Now this cube will have physics enabled on it, meaning it will be affected by other objects, and it will be affected by gravity, for example. So I compile and I go back to my game. I place this cube above my sensing volume, so it's outside the sensing volume of this light, on above it, like that. So when I play the game, we will expect this box to fall down and then falls into this collision volume of the light, right? So that's easy to understand, right? So we have the sensing volume here, and then we have a cube that will fall down. So let me play the game, and you'll see what happened when it falls down. Okay, so I play the game. My character is standing here. I didn't move my character at all. Okay, so everyone please look. So I start playing my game, and then the box in the sky will fall down. but I'm not moving my character. But look what happened when this cube in the sky, it falls down into the light sensing volume. The light also turns on. Okay, but this is not the behavior that we want to have, because imagine you have a room with this kind of automatic sensing light, and then maybe you have some other stuff that's maybe like a cleaning robot that's moving around. You don't want the light to sense these other objects, right? You just want your light to sense whether it's a person that walk into its area. When it's a person, then it will turn on. When it's some other random stuff, then it will just stay off, right? Because that's the purpose of this kind of intelligent light, right? It senses that if you are a person, in this case a character, in the context of the game engine, it senses whether it's a character. If it's a character, then it should turn on. If it's not a character, if it's something else like just a cube or some other random stuff, it should just stay off, right? So how do we avoid situations like this? Maybe someone with a CS background, computer science background, can tell me what's the step that we probably use in this case. What's the sort of the function or the kind of the operations that we need to do in order to. Anyone?钟孝宇，你有没有什么想法？ Yeah.
Add a if logic.
Add a if logic. Okay. If what?
If the object overlap with a pair.
Okay. So this is a very good thinking. So we can add a if statement or a if logic to it, which will determine if it's a character or something else. So anyone can also tell me what's the step of determining whether it's a character or it's something else? Maybe someone can also tell me this step. Like for example, imagine the character. Maybe it's like an object in your programming environment. There is a step that can check whether it is certain object. Can anyone tell me what that step is, or that function or that operation is? Maybe it has a specific name. So in Unreal, it's called casting. Anyone familiar with this concept? So it's a function like what your classmate mentioned. It's a kind of you can achieve it with the if statement, but even with the if statement, you still need to have this step, which is to actually see if this object is of certain class, and that step is called casting. So let's add this sort of function here, and I will explain a little bit more what it does. So let's move away this set intensity to create more space between begin overlap and set intensity. So we have this more space here. Let's again use your left mouse button, drag a white line out of the event begin overlap, and then let's type cast to third. Okay, cast to, and then third person character. You don't need to finish typing everything, but just these few words will show you the necessary result. Cast to, C-A-S-T, cast to, and then you will see the first option called cast to BP underscore third person character. So everyone get this note here. Cast to BP underscore third person character. If you hit compile right now, you'll see that there's an error. maybe this is the first time you'll see this if you never used it before. So whenever you see, whenever you have a blueprint that you are working on, and then you hit compile, it shows you this red circle. It means that there's a critical error, a big mistake in your programming. So if you try to play your game right now, it will definitely not run correctly, meaning there are some bugs that you need to fix. The simple bug here, the simple issue here is that this object pin also needs an input. Let's just connect this other actor from the actor begin overlap into this object, and then compile again. Now it's compiling correctly. So this casting function actually already has the, basically if you open it up, it already has the, if you try to look into the code, it already has the if statement built in. So it's just one function that does all the things that we need. And what casting means is actually just very simple. It basically just check. So for example, when you have event begin overlap, the software or the game engine knows that this blueprint is overlapping with some other objects, right? But it doesn't know what type of object that thing is. It just knows that it's something, but it doesn't know what thing it is. So the casting function basically check whether it is certain things. So you basically just, for example, like you're walking on the street and you find a box like a manghe. You don't know what's inside this box. So you start asking, right? Is it a camera? Is it a mouse? Is it a cell phone? Right? So you start asking it specific questions. So in this case, the overlap event sense something is overlapping, and we use the casting function to ask, is it a third-person character? And it has two outputs. So the first one, which is automatically connected, I can disconnect it. If you want to disconnect certain connections, you can just hold down Alt on your keyboard. Hold down Alt on your keyboard and then click on the pin. It will disappear. So hold down Alt and then click on the connection, or click on the pin. It will disconnect this connection. So it has two outputs, two main outputs. The first one means that it's a positive answer, meaning that you ask the question, is it a third-person character? And the answer will be yes in this case, right? In the first output, it will follow this line when the answer is yes. If it's not a third-person character, it will go to the second output, which says cast fail, meaning it's not a third-person character. Then in this case, it will go to the second output. So what do we do here? We simply connect the first output to the set intensity. Which means when it senses that it's overlapping with something, it asks whether it's a third-person character. If yes, then we set the intensity to this number. If not, then we don't need to do anything. We just stay silent. We don't need to do anything. So we just leave this second output empty. So this is the logic of this casting node. Let's try it. So let's play our game. If you look at my screen, you'll see that when the box falls down this time, the lights will not turn on because it senses that it's not a third-person character, right? But if I walk close to it, it turns on correctly. So that's the function, that's the purpose of this casting node, is that it try to ask the question, it try to determine whether it is getting a specific type, a specific class of objects. So here it might not seem that necessary if you don't have this box falling down from the sky, right? So it seems that it still works correctly. But in the future, when you have more and more complex interaction in your scene, in your game, or in your projects, then you will definitely need this casting node. So try to remember how it works. And also we need to do the same thing to the end overlap. Basically, we want to also determine if this actor that's moving outside of the area, we also want to determine whether it is the third person character. So we basically also do the same thing here. We copy the casting node and move it into the actor end overlap. Okay, I give you maybe 5 minutes. Everyone, make sure you can recreate everything that's on the screen here. Because the steps after this will be slightly more complex, and I will move a little bit faster so that people who understand can quickly follow, and then people who are having trouble can really watch the video recording later on. So make sure everyone can recreate at least what's on the screen right now in the following 3 to 5 minutes. And let me know if you have any questions. Any other questions? If not, I will quickly do a few things that maybe only maybe a few of you will be able to fully follow. But we will then have the break. So during the break, you can maybe ask your classmates, or you can try to figure out how to do it. So the thing I want to do right now is that you see that the light is turning on like right away, right? So it's like its intensity is set to like this large number very, very quickly. However, we maybe in some cases we want to change the number in a more sort of a gradual way, so that the light is not sort of like switching on and off immediately. Maybe you want to gradually turn on and then sort of slowly fade out the light. In this case, let's try to do this. So I will start doing it a little bit faster. So let's move this add end overlap node away. And also, again, I will be doing it a little bit faster. So if you can follow, then that's great. If not, I will take a screenshot or also post the video later so that you can follow again. So let's move this away and then create some space between the after casting to third-person character, and then I disconnect this node. So now we only have a begin overlap, and we have cast to third-person character, meaning we check if it's the character. And now we want to introduce a new node called a timer. So let's drag this wire out and search for timer. T-I-M-E-R, timer. Timer is like, you know, a countdown, 就是一个计时器, right? A timer. And we have this function called set timer by event. So let's create this node, set timer by event. So a timer, you know, as you can think of it, again, it's like a countdown, right? So 就是一个倒数器一样的一个东西。And you can set the countdown value, the timer value here under the time parameter. So for example, if I set to 1, it means that it will start counting down from 1, and then when it reaches 0, then it finish counting. If it's 10, then basically it's like 10, 9, 8, 7, and then all the way to 0, and then it stops, right? You can also loop this timer, so every time it finishes counting, for example, from 10 to 1 to 0, or maybe I set it to 3, easier to say. So maybe it starts 3, 2, 1, 0, and then it stops. But if you enable looping, it will keep counting like 3, 2, 1, 0, and then 3, 2, 1, 0, right? So that's easy to understand. And what it does is that it will execute the function following this timer every time it finishes counting. So for example, if I have this set intensity function after it, what it will do is that not following it. It will execute this event on the left here. It will execute this event every time it finish counting. So for example, if I have an event called set intensity, then it will be like 3, 2, 1, 0, and then it executes that set intensity, and then it starts counting again, 3, 2, 1, 0, and then it do it again. It does it again. Okay. So in this case, let's create a new event by dragging a line from this event pin on the left, and then we have the search bar here. Let's search custom event. Maybe I do it again. So from the event pinned, drag the wire out, and then search custom event. If you just type custom, it will show you the what you need. Add custom event, and then you can name this custom event. We say turn on light, for example. So custom event is a way for you to, create. Basically, previously we have this built-in events, right? Like event begin play, event actor begin overlap. These are all events that are built into the engine. So it came with the engine by default. So custom events is a chance, an opportunity for you to create your own events. So maybe you want certain things to happen under certain situations. You can create these custom events, and then they will be triggered maybe in different scenarios, or you can call functions, and then these functions will execute, will make this event happen. For example, you can also just create like a new custom event simply by right-click, and then also search for custom events. So you can create custom events like this, right? New event, and you can also connect this event to this red pin here. So it's the same. It does the same thing. You can create a new event first, and then you can connect these two together. So it does the same thing. But whichever way you do it, now we have a new event called turn on light, and it also has a execution pin here. So this time, let's drag our set intensity down, and we would think that maybe we just simply connect these two. But let's take a moment to think what this does. Okay. What it does is that it will start the countdown 3, 2, 1, 0, and then it will trigger this event, and then this event will be followed by this function set intensity. But every time it will set its intensity to this fixed number, right? 10,000. So this is not what we want, right? So every time it set it to the same value, so it doesn't really do anything useful for us. What we want is that we want to gradually increase its value. So maybe the countdown is like 3, 2, 1, 0, and then it adds a little bit of intensity, and then 3, 2, 1, 0, and then it adds a little bit more, so that gradually the lights turn on to its full brightness. So here we want to use another new node called interpolation. So we right click and we search for f-interp. So I will zoom in. So you right click and then you search for f-interp. You will find this node. It stands for float interpolation. Interpolation in Chinese is kind of like 差值 or it basically means that it will, if you have two numbers, for example, from 0 to 10, then you can all of the values in between can be seen as interpolations. So if you have this function, it will start from 0 and then 1, 2, 3, 4, 5 all the way to 10. So you can see that it has a few parameters. Current is the current value. For example, if your light intensity right now is 0, then it is the current value. The target value is the the final result, the full brightness value that you want to set it to. For example, here is 10,000, meaning eventually at the end we want to set the light value to reach 10,000. Okay. So how do we get the current value? We get it from our point light, because the current value is not always 0, right? Because every time you execute this function, maybe it becomes 1, maybe it becomes 2. The current value is always changing because your light is turning brighter and brighter, right? So the current value is always changing. So we need to get its current value. So we drag the point light into the graph again, and we drag a new line out from it, and we search for get intensity. So previously we set its intensity, right? We remember the word set, meaning you want to change its value. This time we use the word get. So if you haven't done programming before, also remember this word set and get, right? Very easy to remember. Get meaning that you're reading the value from this node. You are asking it, what's the current value of this property, right? So we say get intensity. So this node will give us the current intensity value of the light, and we plug that into the current value of the f_interp_2. So let me finish the scripting, and then I'll explain more in detail what it does. The third value, delta time, it's a little bit abstract. Let's not try to explain it too much right now, but simply just drag a line out and then say search for get world delta seconds. A little bit difficult to explain. So if you didn't really have a technical background, just maybe try to you don't need to understand it right now, but if you do, it's basically just like when you play video games, you have this refresh rate, right? Or your screen also have refresh rate. Basically, a program also has its own refresh rate. So every delta second, it basically finish all the programming. It runs all the programming once in your entire game environment. Basically meaning all the interaction, everything, it will run it once. So all the interaction will take place. You can think of it as one frame in the whole game world. But yeah, if you find it too abstract, don't worry about it. Just plug this node into the delta time. Get world delta second. And then interp speed, let's just type the number 1, in meaning how much value it will change every time it execute this function, right? So if it's 1, then every time it will increase the brightness by the value of 1. If you set it to 10, then it will increase the brightness every time by a value of 10. So if it's 10, then it will be like 10, 20, 30, 40, right? If it's 1, then it will be 1, 2, 3, 4, 5 until it reach 10,000. So let's go through this whole node again. It's one node that does a lot of things, right? So it basically f_interp_2, what it does, it reads the current intensity value from our point light, and then we set its target to 10,000. So it will set the intensity from the current value to its target value by this interp speed until it reach this final result. Okay, so now we have this set up. Let's point this return, connect this return value with the new intensity node, new intensity pin here under the set intensity. So this finish our setup here. Oh, and also the timer set timer by events. The time here, let's set it to a very small number, like 0.01. So we have a very smooth. So So every 0.0 seconds, sorry, every 0.01 seconds, it will change the light intensity to a new value. So it's a very smooth, very quick transition. So let's not do so much talking. Let's actually see its effect. So let me play my game. So this time when I walk into the area, you'll see that the lights turn on very smoothly, kind of in a very gradual way, rather than just turn to its full brightness immediately. So if I decrease my interrupt speed to a smaller value like 0.1, you'll see the effects even more clearly. So if I play my game, I walk into the area, you'll see that my lights turn on very slowly. Let's see again. So I walk into the area, you see that the lights turn on very smoothly and very slowly. Okay, let's take a 13 minutes break. Let's come back at 8 o'clock. Meanwhile, if you don't need to go to the restroom or drink any water, please try to digest this whole part of the graph and try to understand what it means, and also try to recreate it in your own graph. If you cannot fully understand, just also take a photo of the screen and try to recreate it later. Yeah, so now it's the break time. You can go to the restroom, or you can drink some water, or you can continue working. So I will explain again the whole concept in Chinese again, okay? So that maybe everyone can follow. So if you're having trouble understanding, I'll explain in Chinese. So the testing we already know. Set timer by events, 它 basically create a new， 就是一个新的一个计时器，一个倒计时。这个倒计时就是当我们 enable 了这个 looping 之后，它就开始倒计时这一块的时间。比如说，如果它是如果它是3秒钟，它就是3、2、1，然后3、2、1这样不停的倒计时。如果是一个很小的数值，它就是很快的就归零了，然后它就不停的相当于它很快的在不停的倒计时这样子，这个数值很小。那它每一次倒计时结束的时候，它都会执行这个 event。这个 event 是我们自己创建的一个 custom event， 对不对？那这个 event node 它就会继续执行这一步的 function。那这个 function 是 set intensity， 这个我们之前用过了。但是我们这次有什么不同？因为我们加入了这个新的 f-interrupt， 就是这个 node。这个 node 的功能也是比较重要，它基本上就是说，它有一个 current value 和一个 target value， 它会根据你设置的这个 speed， 它从一个数值的，它从这个一个 current 的数值一直会过渡到这个 target 的数值。比如说，如果 current 数值是1 ，target 是10，它就会，然后你的 interrupt speed 是1的话，它就相当于1、2、3、4、5、6、7、8、9、10一直到10这样子。如果你的 interrupt speed 是0.1，它就是1，然后1.1、1.2、1.3，一直到它到达这个 target value 为止。那我们怎么样知道它的 current value？ 我们从这个 point line 里面直接读出来，用 point line， 然后 get intensity， 我们读出它现在的 intensity， 然后把它发变到这里。所以最后我们每一次的 return value 都是一个不一样的数值，对吧？比如说可能第一次是0.1，然后0.2、0.3，所以我们每一次相当于 set intensity 的时候，都把它 set 成一个 new 一个新的数值，就0.1、0.2、0.3，不停的这样子执行这个命令，直到它最后 reach 这个 target value. So this is the full logic of this part of the graph. Again, if you've done programming before, it's fairly easy to understand. But if not, try to digest it, try to fully understand what it does, what it means, and maybe even ask your classmates. Maybe they explain it in a different way than I explain. And this kind of gradually changing something, maybe it's not so. It seems like it's not so useful right now because the lights, right? It doesn't have to turn on or off gradually. But imagine after we come back from the break, imagine if you are opening a door. So for example, if you have in your project a character walks towards the door, and then maybe it press a button, or it doesn't have to press a button. You just walk close to the door opens, right? A door would not just pop open like from 0 degree to 90 degree like that, right? That's not realistic. a door would open like gradually, right? It will rotate from 0 to 90 degrees. So this kind of effects will be very useful in this kind of scenario. So after we come back from the break, we will see how we can sort of open the door gradually using a very similar technique. Yeah, let's come back at 8 o'clock.
你是为什么会现在决定选择这个？做那你那个之前的学对，就是说，反正就我不知道你，比如说上节课，你觉得跟下来怎么样？因为这个这节课呢，确实要求比较重的，从这个游戏里面看，就是说，一般我第一节课就是告诉学生，要么你有一点3D 的基础，这样3D 的话你就可以快一点；要么你有一点编程的基础，那编程就一般。如果你是就是说完全就是可能会有点难度，因为你的意思可能。那个就是蛮多3角形左右，所以就是如果你确实想要那个，就是继续上这个课的话呢，反正就是我先跟你说，这个课难度肯定是有的，而且这方面花的可能要求也是所以还是要注意长期。可以是的，这个方面我觉得你说没有那个，对，就整个课如果确实要上到那个，我并不想考虑那种。